we have an Atwood pulley system here, which we can see has two masses, mass 1 being bigger than mass 2. And because of the weight difference, we can obviously assume that the block 1 is going to fall down while block 2 is pulled up. And that's all due to the tension force. So we have two free body diagrams here. For mass 1, the force of gravity has to be bigger than the force of tension for block 1 to fall down, right? But for block 2, the tension force stays the same for all the masses, but for block 2, the force of gravity has to be smaller than the force of tension of mass 2 for the block to be pulled up. So let's derive an acceleration for the system. So we'll start with net force equals ma. To find the acceleration, we have to bring the mass on the other side, so this becomes A equals net force divided by m. And the two main forces that are going to be causing this block to fall down are the force of gravity of block 1 and the force of gravity of block 2. But because the force of gravity of block 1 is bigger, let's write it first. So Fg of m1 minus Fg of m2. They're going to be opposing. All divided by total mass. This just means the total mass of both objects. So then we're going to get Fg m1 minus Fg m2 divided by m1 plus m2. And obviously we know that Fg is equal to mg, so we can turn it in as m1g minus m2g divided by m1 plus m2. And we can simplify it further. So in all, we get acceleration equals g times m1 minus m2 divided by m1 plus m2. So now, since we have the acceleration, we can just use F net equals ma for each object, because once we know the acceleration and the mass of, for example, m1, then we can do F equals m1a, which will give us the net force acting on it. Similarly, for mass 2, all we have to do is just do F equals m2 times a. Now let's start by deriving the tension force of the system. So we can actually come up with two different equations to solve for the tension force. So let's start by doing it one way. What we have to do is we have to isolate each object to come up with the tension force. So let's start with mass 1, for example. So obviously net force equals ma, and the net force acting on this mass is F of g and F of tension. And since they're in opposing ways, we'll write Fg of 1 minus Ft equals ma. Right? So we can simplify this further, right? So Fg of 1, we can just write it as m1 times g, since g is constant, minus Ft equals m1a, right? Now, all we really have to do is just bring them to the respective sides. So bring Ft here and bring m1a here. So we get Ft equals m1g minus m1a. That's one equation we can use to solve for these. For mass 2, we see that the two forces acting on it are the tension force and the force of gravity. And since the force of tension is bigger here, we'll write it as Ft minus Fg2, since they're in opposing ways. So net force equals ma, Ft minus force of gravity of 2 equals ma, right, for mass 2. So we can simplify this further. So now we get Ft minus m2g equals m2a. So we can just bring this on the other side. So we get Ft equals m2g minus m2a. And no matter which equation we use to solve for the tension force, these are always going to be of equal values. So let's start by doing an example. So for this example, let's use the equation we derived for acceleration to find the acceleration itself. Okay, so A equals G. We know that G is 10 meters per second squared, so we'll just write it as 10. It remains the same throughout, and this is M1, and this is M2. So we have the masses, so now we subtract them. So 10 minus 5, right? Divided by 10 plus 5, M1 plus M2. And this just equals 3.33333. It's just 3 ongoing meters per second squared. So let's use both equations that we derived to solve for the tension force. So we can only use this equation if we know the mass of M1, and we can only use this one if we know the mass of M2. We can't just have like one mass and use them for whichever we want. That's not possible. Okay, so P1 equals mass of 1, which is 10, times G, which is also 10, minus 10 again, times the acceleration, right? 3.3. And that's just equal to 66.6 newtons, right? T1. Now let's use this one. So the mass of 2 is 5, so 5 times G, which is 10, plus 5 times the acceleration, which is 3.3, and T1 is equal to 66.6. We see that they're both equal. Now let's draw free body diagrams of each mass to find out their net force. So again, we know that Fg equals mg, and the mg on mass 1 would be 100 newtons, because 10 kilograms times obviously 10 meters per second is 100 newtons. And the force on the opposite side is a tension force, which is 66.6 newtons, and that's for mass 1. So now let's think about for mass 2. We know that the force of gravity is 50 newtons, but the tension force, which we can see is bigger, which is obviously what causes this block to go up, is 66.6 newtons. And so quickly we find out the net force on all of these objects. For this one, it's 16.6 newtons, and for this one, it's 33.3 newtons. Interestingly, what we also could have done was just use F net equals ma, because now that we know the acceleration, we could have just multiplied it by the mass to figure it out. So for the net force of object 1, it's just 10 kilograms times 3 which would get us to 33.3 newtons, which we can see here. And for this one, 5 times 3.3, this would have gotten us to 16.6. Alright, that's pretty much it.